So hello everyone, hope you're doing it and welcome back to my channel. Today we are at day 3 of the June daily Leetcode challenge, and we again have a medium level question in front of us. For the last 2 days also we are facing some medium questions, and today finally we are having a question on trees. So as you can see, this question looks very simple. Actually, it's really a simple question. You just need to identify the data structure, and they have also given some hints about it. And finally, you have to implement it. It's a really simple one, I will say. If you're a beginner, then definitely you should try with this question. Let us see what the question is. It's question 1376. Time needed to inform all employees. Okay, as the name says, we will need to inform all the employees some news, and we need the time needed to inform that news. Okay, so the time needed to for all employees to know that news. Okay, so first, let us see what are the inputs given to us. We are given the number of employees here. We are given the employees that is head ID. That means like each employee has a unique ID, right? So similarly, the head ID refers to the ID of the topmost official of that particular employee, right? And similarly, we are given, for example, here for each index we are given its manager. As you can see, the manager of index 0 is 2, the manager of index 1 is also 2, and so on. And we will see a minus 1 here, which means that for this particular index there is no manager, because that itself is the head employee, right? Head employee won't have a manager, right? So in this case you can see the index 2 don't have a manager, because index 2 is the head ID, that is the topmost official of that company. Similarly, there is an informed time of it. Okay, inform time refers to that particular index. That means for index 1, the inform time is, that means to inform its subordinates it will require a 0 time. Okay, that's basically. Similarly, the index 2 will require a time of 1 unit to inform its subordinates. That is something it's given, but I explained it from my knowledge. Let's see the exact words given in the question, right? So there are n employees. N is given in this question, right, as an input. That is fine. With so see, here they have also mentioned the same. There is a unique ID for each employee, right? From 0 to n minus 1. The head of the employee is one with the head ID. Okay, head ID is the input given to us. Okay, for each employee has one direct manager given in the manager array, as you can see here, manager array. Okay, so yeah, array. So manager of I is the direct manager of the ith employee, and so on. Okay, so they've also mentioned about this minus 1 thing. Okay, so the manager, yeah, head of, so the head employee will not have any manager. Also, it is guaranteed that subordinations have a tree structure. So here itself they've given this example. Please take a note of this. This is the hint they are giving here. It will be proceeding like a tree. Okay, you can imagine the head employee with this particular ID. Okay, head ID as the root of the tree, and the tree will keep on growing from. That means the number of nodes along each level will be going on increasing as we go below. Okay, as we go down the hierarchy. So that is what is the idea. Okay, so this was all the information about the inputs given to us. Now starts with the question. Okay. Now the question will start. The head of the company wants to inform all the company employees of an urgent news. Okay. He will inform its direct subordinates, and they will inform their subordinates, and so on. Okay. Until all the employees get the news. Okay. So the ith employee needs inform time of I. Okay. Inform time is the area given to us. It's ith index. Okay. This represents, for example, see here, inform time of is array. Okay, for example, in this case the index 2 is 1. Okay, that means the second employee, that is the employee with the id 2, requires 1 unit of time to inform its subordinates. Okay, that is the idea. The other employee needs inform time of I minutes to inform all of its direct subordinates. Remember that it's only for the direct subordinates. After inform time of 5 minutes, all its direct subordinates can start spreading the news. Okay, return the number of minutes needed to inform all the employees about the urgent news. Okay, this is the question given. uh, this question looks bit easy, but there are some things which you will get to know only after you try your code, and your code will fail some of the test cases. Only then you will get to know the tricks hidden in this. Okay, so let me show that now itself. Okay, so you can see here that there is a parallel execution happening here. What that means is, see, we are at this particular thing is the root of the d, that means it's the head employee. Okay, it's taking some 1 minute of time to inform its subordinates. That is fine, but see this, yeah, the level number 2. Okay, see, this level 2 means, see, this node will take 2 units of time to inform its subordinate. Similarly, this node will take 3 units of time. That is fine, but see, this unit also takes 2 units of time. So what I mean to say is that sorry, not 2 units of time. See, this will also take one time. Okay, so here one unit of time got over, here another 1 unit of time will get over. So finally these 4 5 6 these employees will get to know at the end of time t equal to 2. Okay, that is the basic idea. Here also the same, 1 unit of time already got over, here also 1 unit of time, so 1 plus 1 2. So these 8 9 10 employees also will get to know at the end of t equal to 2. For this particular thing it will take 2 units of time, so 1 plus 2 equals 3, right? That is the idea. So one thing please understand, there is a parallel execution happening here, right? That means for this particular manager, they will inform in parallel to their employees. Okay, so we should not be waiting. That means the idea is we need not wait for these employees to be known before these employees are known. Okay, the idea here is for each the branch of the tree, there will be a parallel execution happening. Okay, they will be informing each of their subordinates parallelly. That is the very basic idea I am informing to you. Okay, so this thing you will be like finding it a bit shocking when you try and get your court cases rejected. That is the basic idea. They have not mentioned about this parallel execution. Basically they are just asking to find time taken, but when you get to see this you will get to know that there is some parallel execution happening, and along each branch it will proceeding parallel. Okay, that is the basic idea. And now let's come to the question. This is the only thing which I wanted to show you. Test all is very clear in the question. So let's start. The first thing that I will tell you is I'm also, as the hint given, I'm also going to implement a tree data structure here, right? Basic tree data structure. Which tree, when I say it not be like a linked list or something like that, making a link below, something like that. It's just imaginary tree, right? We will be doing a BFS in it. Okay, why BFS? Because it makes sense to me. Because see, subordinate will inform all its employees, right? It will take 1 unit of time. That means after that 1 unit of time, all of its subordinates should be ready to inform below the hierarchy, right? So for me, it makes sense to go for a BFS because in this case, it seems logical. See, there are many ways to solve a question. DFS, BFS, both of them you can apply in this case. But I feel BFS should be more logical because that's how the things are proceeding, right? In a parallel execution manner, right? So yeah, first of all we have to store the informations. Okay, because yeah, uh, see in this case we for each index I get to know what is the manager's ID, but for a manager I should know what are its subordinates. That particular thing is not directly given to us, so I will first make a record of that and then I will proceed with the VFS. Okay, so for that I'm making this thing. Okay, subordinate I'm making a separate dictionary. In Python, dictionary means basically a mapping, right? It's a key is getting mapped to a value, right? It's just a mapping. Okay, so what I'm mapping is, see, for each manager ID I'm mapping all of its subordinates. Okay, I will just print and show how it works, but just understand that for each manager I want to make a list of all its subordinates. So whenever I pass the manager's key in this particular subordinate dictionary, the value returned to me will be a list containing all of its subordinates IDs, right? Please have this thing in your mind and let us proceed further. Okay. So if I'm going through each of the index in the range 0 to n minus 1. Okay. So I'm now traversing the manager's array. So manager of I, that means for the zero, this ith index, k is the manager. Okay. K is the manager. If k is equal to -1, that means that I is the head employee, right? I is the head employee. For this case alone, I am not doing anything because I don't want to do anything here. Because see, already I know that my root itself will be the head info, right? Head employee. So I don't need to know what will be the manager. So I don't store them at all, right? Who will be manager of that, because anyway management will come, right? So just it's a edge case. We don't need to store the manager of head employee, right? And anyway, it's a management. Okay. So coming to the important part here. Okay, yeah. So remember, I is the employee, K is its manager, right? So if K is not already in subordinates, we will initialize it, and for the value K, I will allot. Sorry, for the key K, I will allot a list. Okay, for the first element in that list will be the index of the ith employee. Okay, that is the ith value. Okay. Similarly, in the case when K is already existing, that means for some employees K is already the manager. So what we'll do is we'll simply append. Okay, because if this list is already created here, so when we'll come to this use case, that means K is already a manager and it's already declared that. So we'll just appending the ith value in that list. Okay, so this whole thing will be storing all the, for example, for each manager we will storing the subordinates. I'll just quickly print and show you how it works. Then we will be proceeding with the traversals. Yeah, I am okay. Let me go for some big test case. Yeah, so you can see for the zeroth employee, these are the subordinates. For the first employee, these are the subordinates. For the sixth employee, these are the subordinates, and so on. Okay, it will be keep on going. Okay, that is basic idea. Let me quickly hide it now because this is also consume some processing time while running the solution. Okay. Then, as you may be knowing, this is a tree, and I have already told you that I am interested in BFS traversal. Okay, see, you can call it BFS or BFT, whichever way you want. The idea we are going to do a breadth first traversal here. Okay, it need not be called as such, but this term is very famous, and because beginners will find it bit, they will be knowing only BFS and not BFT. That's why I use this word most often, so that they get to know something familiar, right? That is basic idea. So as you may be knowing, always a queue will come whenever we talk about the breadth first traversal, right? So and there will be another. In this case, we'll also need to record the time needed, okay? Because that will be the final answer. Because here they're asking return the number of minutes needed to inform all the employees. Okay, so we'll need this variable here. Okay, now what are the things here? See, this is the queue is in form of a list, right? Now see the element of here. Each element consists of two parts. Okay, so for j integer, next part is the id. So what is this integer? This refers to the time at which this particular id got to know the news. Okay, please remember this thing very carefully, otherwise you will not understand the solution. This refers to the time at which this particular employee got to know the news, because head id is the going to be the root, right? Root will get to know the news at t equal to 0. That's why this is 0, right? Now we'll start the BFS traversal. Okay, till the queue is not empty, this whole code will be run, right? What we are doing is c time refers to the current time. Okay, c time means current time, and node is the index of the node which is being popped. Okay, so we are going to pop the leftmost element of from the queue, and yeah, we are segregating its value. See, these see, we are popping zeroth value, right? Zeroth value refers to both of these. Okay, these together will be popped out. We are not segregating them between c time and node. Okay, node refers to the id which is being popped. C time refers to the current time. Okay, the current time. Okay, now because current time is popped out, see, we know the current time, right? So time needed will be the max value of the any previous time and the current time. Okay, so as you can see, we are just updating, because if time needed was previously 1, now the current time is 2. That means 2 will be the time needed. We will conclude that. So any max time among all the 6 times will be the time needed. So we are just updating time needed, okay, among the maximum value. Now comes the interesting part. Okay, now comes the part when which will be updating the queue, right? So if the node popped out is in subordinate, that means if it is a manager of some other employees, only then it will be in subordinate, right? If it is a manager of some employees, only then we'll be proceeding further. And what is that? Now we will be going through that subordinate of node. That means I will represent each of the subordinates of the node manager. So that means I will represent the subordinates of the manager whose ID is node. Okay, we'll go through each of its subordinates. What we'll do is we will be including them into the queue now. Okay, now, remember one thing, this particular node, okay, this particular node will take some time to inform its subordinates, okay. So with their subordinates will get to know the news in this much time, okay. Current time is the time in which node itself got to know the news, and node will pass that information to subordinates after this much time. After this much time, okay. This is the time when node got to know the news. Okay, this particular node, this is the node, got to know the news in C time. That is the current time. Current time plus the time needed to inform its subordinates, which is represented by this. Okay, this is in total will give me the time needed for its subordinates to know the news. Okay, and I is the subordinate ID. Okay, so what from where this is coming? Okay, this is already given here, right? See, inform time is array. If you for any index I, it will tell me the time it will need for its to for that particular ID to inform its subordinates, right? That is what is this. Okay, so C time, that is the current time plus the inform time needed to inform its subordinates, and the ID of the subordinate that will be subordinate to the queue. Okay. Now, let me make it one point very clear. See, normally whenever we do this kind of traversals, especially BFS, we will be keeping a set called visited, okay, which will help us to to classify which nodes are already visited so that we don't visit them again. But I think this is question I also had as a beginner. But let me tell you one thing. So those kind of things are needed when we are dealing with graph. Okay. In case of tree, there is no scenario where see, graph means any kind of nodes can be there, any kind of edges can be there. Okay. But in a tree, the direction of how the nodes will be generated is going to be hierarchical way. Okay. It will be in a hierarchical way. Okay. That means a node will only be connected to its manager or its subordinate. These are the only two possibilities for it. Okay, it won't be connected to anyone else. Okay, so we don't need those kind of structures here because we know there won't be a cycle existing. Okay, please make this point very clear. When we talk a tree, it will be always acyclic. Okay, it will be called a DAG. Okay, directed acyclic graph. Okay, so yeah, please make this point very clear why we are not using those visited or that particular set kind of data structure. Okay, yeah. So friends, yeah, these things will be happening, and this particular node, that is the subordinate node I, will get to know the news at this particular time. Okay, so whenever this node will now be explored further, that means whenever this I, see, it's inside of the queue, there will be a time when it will be popped out. Okay, so now node will be I after some time. Okay, so this particular time then will come here, then it will come here, and the time will be updated. Okay, similarly it will be keep on happening. Okay, for till we come to the leaf nodes. Okay, till we come to the leaf nodes, and finally time will be updated. And when this loop ends, that means when we are done with exploring all the nodes including the leaf nodes, we will be returning this time needed. Okay, so if I run this and show you, can clearly see it's clearing some of the all test cases. And one thing, let me make it very clear. See, there are two test cases given in this question. The third case is something which I myself inserted to see if it's really working or not. Okay, this is my own test case, so you need not worry about it. These two were the ones already given. Okay, by default they were given. So yeah, friends, that was all. If we talk about the time and space complexity, because see, we are using a data structure to store the subordinate. Okay, that it will, what it will store, it will store the managers and the subordinates. Okay, if you talk about the time complexity, it's obviously going to be O of v plus e. Okay, where v represents the vertices, that is nodes, and e represents the number of edges. Okay, and if you talk about the space complexity, in terms of space complexity, see what are we are using, we are using only subordinate array. Okay, subordinate array means it will show subordinates and all its nodes. Okay, in the worst case scenario, it can be of of n square in the worst case scenario, but yeah, that is the only thing. In all other cases, it will be less than that only. And time complexity, it will be O of u plus e. So yeah, friends, that was all for today. If you have any doubts, please do comment below. And I feel this was a simple question, and there are many ways to do it. You can try DFS also, but logically speaking, I felt BFS should be more suitable, and I felt more easy to explain it to myself why BFS should be more suitable, right? So yeah, friends, that was all for today. See you tomorrow. Thanks a lot.